In one of the most spectacular recent developments in space research, data from NASA's InSight probe suggest the existence of a gigantic water reservoir lying dormant beneath the surface of Mars. This underground reservoir is believed to be large enough to flood the entire planet to a depth of 1 to 2 kilometers. Hidden within the cracks and pores of the Martian crust, this cool water may not only provide answers about Mars' watery past but also raise the tantalizing possibility that life could still be slumbering in these hidden depths. Mars, also known as the Red Planet, owes its iconic color to iron oxide dust covering its surface, giving it a dry and cold appearance. The dust is a fitting symbol for the barren, hostile environment that the planet presents today. However, if we turn back the clock by about 3 billion years, a very different picture of Mars emerges. Scientists now believe it is almost certain that Mars was once a much more dynamic and life-supporting world, featuring rivers, lakes, and even vast oceans. Calculations have shown that the ancient Martian oceans could have covered as much as 75% of the planet's surface. But over the course of several dramatic climate changes and the gradual loss of its once dense atmosphere, most of that water disappeared. The question that arises from this loss is, where did all the water on Mars go? Data collected so far indicate that the polar ice caps of Mars are not large enough to store all the water from its former oceans. The same conclusion applies to the water ice deposits that have been detected below the surface in the planet's mid-latitudes. This has led many researchers to speculate that Mars lost most of its water to space due to its lack of a magnetic field. Without this protective field, the solar wind was able to gradually strip away parts of the Martian atmosphere, along with its water. However, there is another possibility: Mars may have retained its water deep within the planet's crust. To explore this alternative theory, a team of scientists led by Vashon Wright from the University of California, San Diego, examined data from Mars quakes recorded by NASA's InSight lander. This mission, which operated from 2018 to 2022, collected seismological data from beneath the Martian surface. While previous studies suggested that there was little to no water in the crust down to a depth of 300 meters at the InSight landing site, Wright's team decided to look even deeper. The researchers focused on the mid-crust of Mars, located between 11.5 and 20 kilometers beneath the surface. Despite the average temperature on Mars being a frigid -68 degrees Celsius, the underground regions at this depth could be warm enough to allow for the presence of liquid water. Previous analyses had already indicated that the mid-crust was likely porous, consisting of fractured magmatic rock with many cavities. Using advanced seismic data, the team developed a mathematical model of the rock physics, a technique commonly used on Earth to detect oil deposits. To their surprise, the data revealed that not only was the mid-crust porous, but the cracks and fissures in the rocks were filled with liquid water. This finding led the researchers to conclude that there could be an enormous underground reservoir of liquid water, potentially large enough to form a planet-wide ocean. If this discovery proves to be representative of the entire planet, Mars may have stored enough water in its crust to flood the entire surface to a depth of 1 to 2 kilometers. This underground reservoir could also explain the disappearance of the Martian oceans. Instead of being lost to space, the water may have seeped into the depths of the Martian crust, where it has been preserved to this day. This groundbreaking discovery has raised the question of whether life could exist in Mars' underground water reserves. Although accessing this water would be impossible with current drilling technology, which cannot reach such extreme depths, life itself may have already found a way to survive there. Similar examples on Earth suggest that life can thrive in the most extreme environments. In 2021, Antarctic researchers discovered sedentary organisms living 900 meters beneath the surface of the Filchneron ice shelf, far from sunlight and any apparent source of food. Additionally, Earth's deep biosphere is home to various forms of life, including bacteria, viruses, and fungi, which have been found living in ocean sediments, volcanic rocks, and even solid bedrock. Michael Manga, a co-author of the study from the University of California, Berkeley, speculated that Mars' underground water reservoir could also support life. As water is a key ingredient for life as we know it, the presence of liquid water beneath the Martian surface suggests the possibility of a life-friendly environment. Although no direct evidence of life on Mars has been found so far, the discovery of this reservoir provides at least one potential habitat that could support microbial life. The search for life on Mars has been ongoing for decades, and NASA's Perseverance rover has been a key player in this effort. Since landing in the Jezero crater on February 18, 2021, the rover has been exploring the Martian landscape, collecting soil samples, and searching for signs of ancient life. One of Perseverance's most significant discoveries to date took place at the northern foothills of the ancient Neretva Vallis River Valley, where it found a unique rock formation dubbed Shava Falls. This formation is marked by broad white sulfate veins and a darker, reddish material that suggests the presence of the iron oxide mineral hematite. Within this deposit, Perseverance detected small patches of material that could indicate the presence of organic compounds. The discovery of these organic molecules is particularly exciting because similar compounds on Earth are often associated with microbial life. Spectrometer analyses of the rock at Shava Falls revealed organic carbon compounds, which could be the remnants of ancient Martian life. These patches, which are surrounded by black material rich in iron and phosphate, resemble the traces left by microbial organisms on Earth. The process of microbial reduction of iron oxide can release iron and phosphate, creating similar formations to those found at Shava Falls. Water once flowed through this region, potentially creating a life-friendly environment for Martian microbes. The combination of water, organic carbon, and the mineral composition of the rock suggests that the site could have been home to microbial life in the distant past. While these findings are promising, NASA emphasizes that organic molecules can also form through non-biological processes, such as volcanic activity. The true origin of the deposits at Shava Falls remains unknown, and remote sensing methods, including laser and X-ray analysis, have been exhausted. To fully understand the significance of these findings, scientists will need to bring samples back to Earth for more in-depth analysis. Once these samples are retrieved and examined using advanced laboratory techniques, we may finally determine whether Mars once harbored life. Until then, the tantalizing possibility of microbial Martian life remains an open question. The discovery of a possible vast underground water reservoir on Mars brings new urgency and excitement to future missions. While current technology limits our ability to access this water directly, the possibility of such an extensive water reserve reshapes how scientists think about the planet's past and its potential for sustaining life. The realization that water, a fundamental ingredient for life, could still exist in significant amounts beneath the Martian crust might inspire new missions aimed at probing deeper into the Martian subsurface. NASA's Perseverance rover, for instance, is laying the groundwork for the return of Martian soil samples, which could provide valuable clues about whether the subsurface environment ever hosted life. These samples will help scientists determine the mineral composition of the Martian crust and whether the ancient waters of Mars left behind chemical signatures or organic compounds that suggest microbial life once existed there. In the future, we could see missions equipped with advanced drilling technologies, such as cryobots or more robust seismic equipment, that might be capable of probing deeper into Mars' crust. If scientists could access the water-rich regions of Mars' middle crust, it would mark a tremendous leap forward, not only for understanding the planet's history but also for future human exploration. Water is essential for sustaining human life, and having access to subsurface reservoirs could drastically reduce the logistical hurdles of human colonization by providing a local source of water for drinking, agriculture, and oxygen production. Beyond its significance for understanding the planet's history and potential for life, this vast underground reservoir also has implications for the concept of terraforming Mars. Terraforming is the hypothetical process of transforming a planet's environment to make it more Earth-like, allowing humans to inhabit it without the need for extensive life support systems. Water is a crucial factor in any terraforming scenario, as it would be needed to create an atmosphere, support plant life, and maintain surface stability. If Mars still contains substantial amounts of water beneath its surface, future technologies might be able to bring this water to the surface. It could contribute to creating an environment where human life might one day thrive. However, the technical and ethical challenges of terraforming are enormous and would require further research, collaboration, and technological breakthroughs. Thanks for joining us on this incredible journey into the mysteries of Mars. If you enjoyed this exploration, don't forget to hit the like button and subscribe so you never miss an update from us.